Today we're going to talk about the rules of exponents and scientific notation. Now, in general, there's a handful of exponent rules. Now, I'm going to give you 6. Now, you could probably simplify this down a little bit, but I'm going to give you 6. Okay, so we're going to go through them first, and then we'll talk about them. So the first rule is this: if I have a to the m times a to the n, that equals a to the m plus n. Okay. Second rule: if I have a to the m divided by a to the n, that is equal to a to the m minus n. So far, so good. Third rule: if I have a to the m to the n, that is equal to a to the m n. Okay, so a couple things for us to kind of take note of. Okay, one is that if you notice that all of these rules, now there's only 3, we have 3 more to go, that all the bases are the same. And also notice that the base doesn't change. Okay, so it's a to the m times a to the n equals a. Okay, it's not 2a or a squared. Okay, and then we're going to add our exponents here. Here we subtract our exponents, and here we multiply our exponents. So let's go with the fourth rule. Fourth rule says if I have ab to the m, that is equal to a to the m b to the m. Okay, so essentially it's like you're distributing the exponent. The next one actually has 2 parts. It says that if I have a to the negative n, that is equal to 1 over a to the n. And the opposite's true as well. If you have 1 over a to the negative n, that becomes a to the n. And last but not least, a to 0, anything to the 0 power is equal to 1. Now I'll give a little background or an explanation as to why all these things are. That'd be a good thing to ask your teacher. But we're going to just kind of jump right into actually using all these. Now, the thing about exponents is, or for you to understand, is that there's no order of operations when it comes to these. You can do them in any order you want. Okay, so the other thing is that you're going to have several problems where many of these are used at the same time. So you have to kind of pull apart rule after rule and just keep going through and simplifying. So for instance, let's take a look at this first one that we have right here. So what I'm going to do is I'm just going to go through and see what we can do. So there's nothing with this, but here I notice we have an example of rule number 4 where we can distribute. Okay, it's actually a combination of rule 4 and rule 3. So as I rewrite it, I'm going to get a to the 4th, b to the 3rd. Now as I distribute this in, now right here this becomes like rule number 3, where I'm going to multiply my exponents, and then this one just becomes b to the negative 2. Okay, so what else can I do? Well, notice here, this is all multiplication. This means the same thing as this. So here I can combine these. That's rule number 1. So I'm going to add exponents. 4 plus negative 4 is 0. Here add exponents. 3 plus negative 2 is 1. Anything to the 0 power, according to rule 6, is 1, so I just get b. That's my answer. Okay, not too bad right there. Alright, well let's try the next one. Okay, so the next one gets a little kind of small, so let me write this again. 3x to the negative 2, y to the 3rd, over 6x to the 5th, y to the negative 6. Okay, so looks like here I can reduce. These are just coefficients, so I can reduce those. So I get 1 and 2. Here we can go through and we can subtract. Okay, so according to rule number 2. So if I were to subtract negative 2 minus 5, I'd get x to negative 7. And then here, 3 minus negative 6, I would get y. Okay, it's 3 minus negative 6, so that would become y to the 9th. Now I'm not done because I have a negative exponent here. And if you notice here, this rule says if I have anything to the negative exponent, you essentially just drop it to the bottom. Okay, this is like a to the negative n over 1. You just drop it to the bottom and it becomes a positive. So that's what I'm going to do with this part. So I'm going to get 1. This drops down. Y to the 9th over 2x now becomes positive. So clean it up a little bit. Y to the 9th over 2x to the 7th. Okay, let's try another one here. Again, it's kind of written kind of small, so I apologize. Alright, well this one might seem kind of funny here, but let's give it a shot here. Looks like I have, it looks kind of odd here, but again, let's just pay attention to what's being written. This whole thing is the exponent, and so is this. So if I have 5 to this divided by 5 to that, okay, that's not really any different than if it said 5 to the 5th over 5 squared. What would you do in this case? You would just subtract 5 minus 2. Oops, I didn't mean to put equals there. So in this case, what do? You just subtract this minus this. So it's equal to 5 to the 3x plus 1 minus this. So I get 5 to the 3x plus 1 minus 3x minus 3. So we get 5, 3x and negative 3x go away. 1 minus 3 is negative 2. Now you can't have 5 to the negative 2, so that is, again, rule number 5. So we're going to drop it down, 1 over 5 squared, which is 1 over 25. There you go. Okay, so as you can see, there's a lot of steps a lot of times, and that's one of the biggest problems that people make often is they try and do too much in their head. Okay, so last one. Let's see if I can clear out a little bit of space here. So let me rewrite this one last time because this is, again, kind of small. 3a to the 4th, b to the negative 3rd, times b to the negative 2, a to the 3rd, to the negative 1. Okay, so what I would suggest is I would distribute this. So I would get 3a to the 4th, b to the negative 3rd, times b squared a to the negative 3. Now you can put those together as one big fraction. So that's what I'll do. So I'm going to write it as 3a to the 4th b squared over b to the negative 3, a to the negative 3. Now you can do one of two things here. One is you can apply Rule 5 that we have over here. We can apply Rule 5, where if you have a negative exponent up on the bottom, you can bring it to the top. Or, if you notice down here, we have b's and we have a's. We could apply rule number 2, where you subtract exponents. So it's your call. I'm going to actually apply Rule 5, and so I am going to take these variables with negative exponents and move them up. So it becomes 3a to the 4th b squared. I'm going to move this b up, so it becomes b to the 3rd, this a up, a to the 3rd, and there's nothing left on the bottom, so I don't need a denominator anymore. And then finally, I can combine. So it looks like my a to the 4th and a to the 3rd is 3a to the 7th, and b's become b to the 5th. And there you go. There's using our rules of exponents. Now, one of the things that we need to keep in mind is that we need to keep applying these rules of exponents as we get into other things. For instance, like scientific notation. Now, before we do anything complicated, let's do just some simple review. Let's remind ourselves. In order to go from scientific notation to decimal notation and vice versa. Well, first of all, let's talk about the basic rules. Basic rules is this. The scientific notation follows this order. It's a times 10 to the n power. Okay, where a is greater than or equal to 1 and less than 10. Okay, and n is an integer. Okay, so in other words, this has to be a number from 1 up till 9 point something, and this is going to be an integer. All right, so how do we do this? So let's go from decimal notation to scientific notation here. So all you do is we're going to simply take our decimal in this case is right here, and I'm just going to move it until this number becomes a number from 1 to 10. So 1, 2, 3, 4, 5, 6. So get 4.2 times 10 to the 6th power. And why do we write it like this? Well, simply because if you were to multiply out 4.2 times 10 to the 6th, you'd end up with this number, 4,200,000. Well, let's try a small number. What if I had a really small number like this? Again, I'm going to rewrite it so it's this number becomes a number between 1 and 10. So I'd go 1, 2, 3, 3.56 times 10. But this time, because it's a really small number, I'd end up with to the negative third. Okay, let's go backwards. So 3.6 to the fifth times 10 to the fifth. So I would just simply take that 5, and that's how many spots I'm going to move my decimal. So 1, 2, 3, 4, 5. And then just fill in with zeros. So it's equal to 360,000. Versus one like this, I take my 1, and it says negative 6, so I'm going to go this way. 1, 2, 3, 4, 5, 6. Fill in a bunch of zeros. So I'd get 0.000001. So pretty easy going back and forth from scientific notation to decimal notation. But what if we go through and we do some operations with it? For instance, what if we multiply? Well, if we're multiplying, that's a piece of cake. Because really, all this is all multiplication. It's 5 times 10 to the third times 1.2 times 10 to the sixth. So just multiply stuff that you can. Well, I can multiply 5 times 1.2. That ends up being 6. 10 to the third and 10 to the sixth, that's our very first rule of exponent, is we just add our exponents. So it becomes times 10 to the ninth. So it's 6 times 10 to the ninth. Pretty easy. All right, well, let's do this one over here then. How do I do that? Well, let's multiply. Let's see, 6.1 times 2.3 is 14.03 times 10. Okay, so let's combine those, times 10 to the seventh. But what's the problem with that one? Well, the problem is that this number is not between, or is not from 1 up till 10. So we need to make that. So that means I have to move my decimal one spot over, 1.403. Now, how does that affect this exponent here? Well, the way it affects it is it's going to increase it. Because if you think about it, you were at 14.03. So in order for us to move to the left, that means there's essentially one more decimal place that's been moved. So our 7, would go up to 8. Plus, also, if you think about it, if you were to change this to decimal notation, if you were to move this over 7 times, that'd be the same thing as if you were to move it from here 8 times. Okay, last one. I'm going to write this bigger. I don't know why these are so small. I apologize. Okay. So rules here are the same as what we were talking about up here. Here, I notice I can go through and I can just reduce that. Well, that's just going to be 6.1 times 10. Here, this is our second rule of exponents, where I subtract my exponents, and I get 10 to the fourth. It's incorrect scientific notation, so I'm done. And there you go. There's a quick review of our rules of exponents and scientific notation.